Good afternoon, everyone. Welcome to Global Summit. Thank you all for coming to the session. The session is on observability with OpenTelemetry. Before we get started, how many of you are familiar with OpenTelemetry? I know quite a number of you are, and quite a number of you it's new. Lovely. All right. So today's session, here's our agenda. We're going to talk about what is observability, the overview of observability, in case any of you are stumbled into this session saying, gee, I don't know what observability is, which seems highly unlikely, but I'll zip through that a little bit. We'll talk about what is OpenTelemetry and how OpenTelemetry fits into the observability world. They'll do a demo of OpenTelemetry and IRIS, and then we'll kick it over to my friend Michelle Stolwyk, everyone, Director of Engineering for our Data Platforms team, who will be my co-presenter with me today. We'll be talking about what's coming up next in our pipeline. So with that, shall we begin? All right. So what is observability? Why do we care about it? 40 years ago. That's a big number. I shouldn't talk about numbers like that. Long ago, when I first started in this tech business, our data centers were a lot simpler than they are today. We had the mainframe and the tape machine. Those were all singular, connected by the Ethernet cable into, the Delny or whatever our network gear it was, right? It was all very simple. There wasn't a whole lot to it. And observability was done by, you would have an operator running on the system looking at the log files, right? That's pretty much what observability was. But over the last 20 years especially, we've seen the complexity of the modern data center explode. Microservices obviously had a big part in that. Network-defined or software-defined storage, software-defined networks, all of those added a lot to it as well. Things like Kubernetes, containers, all of that just add a lot more to the puzzle of how do I know, is my service running successfully? And that's ultimately the question that we're trying to answer with observability is, are the customers experiencing the thing that they should be experiencing in the right way? So we've got a lot more data than we've ever had before. So over the last few years, there's been a lot more focus on standards, standardization of, hey, what are the signals that we collect? What does it mean to collect these signals? How do we collect them? And that's where, so before I get into that, I should talk more about what are the signals, right? There we go. So there are three main types of signals that we like to talk about in the observability space. There are logs or events. These are things that happen at a point in time. This is what, again, 40 years ago, what we were doing way back when. Hey, at some point in time, I log a message that said, hey, failed to write to disk, or whatever it was, right? Metrics. So metrics are, another thing that have been around for quite a long time. These are numbers that we plot over time. So CPU utilization and memory utilization and, percent full of your disk and all of that kind of stuff. And those are both really still very critical sources of signals. The one on the right is called traces. You may or may not be familiar with traces, and you might be thinking it's something slightly different from what it is. So traces is around, especially helpful in the microservices world, where you have microservice A, request comes in from a user to microservice A, that then turns around and sends it to microservice B, and then C, and that gets passed along to some other microservice. The trace can let you know, oh, this same request went from this particular machine to that particular machine to this other machine, and how long it took at each of those. And if you can visualize that, that's really, really powerful. These things are called spans and all of that. Michelle's going to be talking a lot more about this in just a minute, so I don't want to steal all of her thunder. But what we see here is, over the years, we've also put in APIs into IRIS in support of these kinds of signals. So there's the structured logs API and the general logging infrastructure we've had for a long time. The metrics API, which was added, I don't know, 10 years ago. Maybe not 10 years ago, but certainly before 2020. And the Trace API, which, as I said, is going to be talked about in just a minute. So where does OpenTelemetry fit into this picture? So OpenTelemetry is a project of the Cloud Native Computing Foundation. The CNCF is part of the Linux Foundation. They are the part of the Linux Foundation that brings you Kubernetes, but this particular set of tooling is not specific to Kubernetes. Works great in Kubernetes, as does many other things, but OpenTelemetry is not a Kubernetes thing, so don't let the fact that it's a CNCF project kind of bother you. And it started by merging together two of the standards for collecting signals. There's one that does traces and there's one that does metrics, and they said, you know what, we should come together and have the same kind of, share that infrastructure. And that's the birth of the origin story, I should say, for OpenTelemetry. So the idea here is that they provide libraries for instrumenting code. They provide libraries for gathering the signals together, for filtering the signals, for sending them along, for collecting them, and for distribution to an observability platform. So what does that look like? What does the data flow in OpenTelemetry look like? What are they expecting? What are we expecting? So you start with some client application like IRIS with some API. In our case, it'll be an object script API because we're IRIS. But you could just as easily, in Java, there's a Java API, all of that. And you say, oh, I'm going to write my signal. So write a log message, or I'm going to set a metric or whatever. And that goes to the OpenTelemetry SDK, and that exports it to something called a receiver. So the receiver, collector, and exporter are all kind of run together in one process. But there's three big parts to it. There's the receiver, which collects data. So our IRIS process will be sending data to the receiver. The receiver then passes it along to processors so they can filter stuff and they can batch things together. There's a lot of complexity that you can do there that lets you decide, how do I send this message over to my observability platform. Then it exports it to what they call a telemetry backend. It's really your observability platform. And the beauty of using an industry standard like OpenTelemetry, and it's really, you might look at it and say, gosh, this standard is only 5-6 years old. It has taken over the industry. It really has. So there are hundreds of observability platforms that all speak the OTel standard. So nothing there that you have to worry about like, gee, does my platform support OTel? In all likelihood, it does. For those of you who are standing in the back, there are some seats up front if you would rather be sitting. All right, so we're at the demo portion of the show where I want to show you, so what I haven't explained, what we've been working on. So we have been working on, big surprise here, having a OpenTelemetry exporter built into IRIS directly. So this means that if you're using OpenTelemetry, your signals that you generate from your IRIS applications can go straight to your observability platform where you can generate charts, you can do alarms, you can do all kinds of things, whatever your observability platform enables. So we're going to be demoing that today. It is not out yet. I know that's one of the questions some of you are going to ask. Hopefully it will be out shortly. You can ask Michelle that question. No, you don't have to ask Michelle. So here's what the demo was that I put together, and then I'm going to walk you all through. We have a Kubernetes cluster. I'm doing it in Kubernetes just because that's easiest for me. That's the Kubernetes cluster is running IRIS, and it will be exporting all of the IRIS signals to the OpenTelemetry agent, which will then pass them along to CoreLogix. CoreLogix is the observability platform that we use internally at InterSystems. This is not an ad for CoreLogix. It'll work just as well for all the others. And we're going to generate some load against this with our speed test. Those of you who've been with InterSystems for a while probably have seen the speed test like 27 times by now. It just generates load. As far as this application is concerned, I'm just using it as a load generator. And I've highlighted a few of the things that I'm going to configure, but I'm going to walk you through that as well. So now we get to the really interesting part. Interesting for me, which is I pre-recorded this demo. And I'm going to try talking over the pre-recorded demo, which is not going to go well. So just manage your expectations here. All right. Let's assume that it is playing. So let me bring this back up. So today I'm going to demonstrate IRIS generating the OpenTelemetry signals and an observability platform consuming them. The demo is running in Kubernetes, and I borrowed the load generator from previous years to push some load against the system. What we're seeing here is a tool called K9s that is, okay, why is that not full screen? Sorry, I'm just now noticing that you're not seeing what I'm seeing. Great. What you're seeing here is K9s, and by now the video should have gone past that. So let me just. All right, I think it is. All right, so the configuration here is in the IRIS cluster YAML file. This is just how I set up the demo. How many of you have used Kubernetes or IKO before? Oh, a whole bunch of you, people after my own heart, thank you. For those of you who've not, this is just a great way of describing how an IRIS instance should be configured, or an IRIS cluster should be configured. So there are three main parts to any IRIS cluster definition. There's the data section, which is your ECP server. Where is your data stored? There's the compute section. The compute section talks about what are your ECP clients. This is how do you scale out, right? If I've got some user workload, where do I put the user workload? You put them against ECP clients. And then we'll describe a web gateway as part of the topology as well. The web gateway is, well, where the web gateway is running. Right, so what goes into the data part? So you talk about which version of the IRIS container you want running. So it could be ours or it could be yours that you built. What compatibility version is it? Is it running IRIS 24.1, 23.1, whatever you want? You can also say, again, sorry, what am I doing here? There we go. Right, so hold on. I'm going to pause that if I can. So in the data section, what it showed you, and I'm going to go back and show that again. What it showed you is is that you set an environment variable for where the receiver should be for your OpenTelemetry data. And I did not go back quite far enough. In the compute side, I'm saying, okay, the same thing. I'm going to set that same environment variable, but I'm also going to be setting up the horizontal pod autoscaler so that it will add more compute servers as the load goes up. And I'm doing that just to make the demo more interesting, because then we'll see more interesting data as more servers get on board. You're seeing more data flowing into our observability platform without you having to do anything. We're also configuring all of this with a CPF file. In the monitor section, there's 4 things that you can set. There's OTel metrics. You turn that on to turn on exporting of metrics via OpenTelemetry. OTel interval says how often in seconds you should be sending the metrics information along the OTel pipe. OTel logs turns on logs for OpenTelemetry. An OTel log version, in this case I'm saying warnings and up, should be sent to OpenTelemetry. So you might not want to send all of that debug level information that you're probably not even collecting today, but if you want to, you certainly can send all of that to your observability platform. And all of this is set in CPF. You don't have to set it in CPF, but certainly I find it a lot easier to set all of these things in CPF. You can set them in the Management Portal UI. There's a page in the Management Portal that has those same boxes, right? You can enable metrics and what the interval is, as well as the logs and the warning and the log level. So going back to K9s, our Kubernetes visualization tool, we see that we have the compute node running, the data node running, and the web gateway running. We also have a bunch of other pods running that I haven't talked about. Those are all the load generator. Those are the HTAP speed test. So speaking of that, let me switch over and start the HTAP speed test. There we go. This is a translytical workload that we're generating here. Translytical is a term that Gardner invented for running transactions at the same time as queries against a database. We run this test. What it will do is it will tell all of those load generator pods that you saw running in Kubernetes, hey, throw as much work as you can against this IRIS instance. And that's exactly what it's doing. So it's loading making 10,000 queries a second against the database. And what we'll see is that after a minute or so, Kubernetes will say, hey, the load is really high. I'm going to start up another compute node to handle that load. The reason we want to see this is we want to see all of this data flowing into CoreLogix, because the point of all of this is to just generate some interesting data for us to see up and running in our observability platform. So let's go over to CoreLogix. Again, it's not an ad for CoreLogix. This works just as well for Datadog or Dynatrace or Signos or whatever observability platform you want to be using. So this dashboard is one we've created for this demo. It's very, very similar to what we use in production. And it's showing you things like CPU utilization on the servers, number of database reads, number of global references. You'll see these numbers are starting to creep up a little bit, right? The CPU utilization has gone up here. The number of global references has gone up. These numbers are a little bit delayed because we said it collects the data every 10 seconds, so you're only going to see this update every 10 seconds or so. And then you'll start to see, and the number of SQL queries, SQL commands have gone up, and you'll start to see things like the number of, start to see other servers being added as well. So this becomes more colorful as you see, for example, these yellow lines are, oh, it added another ECP instance. So you're starting to see load on those new ECP instances as they appear. Let's see, what is next in our demo? I'm going to bring up my script, which I apparently cannot have that up and running at the same time as this is running. That's what I learned. All right. We are, yes, so we're starting to see here, we're starting to see lots of messages from number of queries per second. You could see a lot more messages. So we'll turn off the load test here. I think you kind of get the idea of it. And now I want to talk about, hey, what is it that you need to do in IRIS to take advantage of this, to publish your signals through this same mechanism? And it starts very simply. It starts with, let's write a message to, a log message. Nothing special about that, right? You know how to write log messages. So what we'll see, hopefully in 1 second here, is I will paste in a message some object script I'm sure you've never seen before, write to console log. This is exactly what you've been doing for the last, 20 years in IRIS. And you give it the same parameters that you're accustomed to. You give it a message, you say, hey, do I want this distributed on the output, on the operator log as well. You give it a warning or priority level. That's the word I was looking for. So in this case, I think it's a 3 is a fatal error, if anyone else remembers. It's a high priority message. So that's it. Like, your existing code will just work, and it will just send these messages to OpenTelemetry as well as to wherever else you are sending your messages today. Let's talk about metrics. How many of you know about the metrics API? How many of you have built your own metrics? Oh, more than 0. I am delighted by this. So you can add your own metrics for your own application needs. IRIS comes with a whole bunch built in already, but you can add your own just by creating a class in IRIS. And the documentation goes over all the details of this, but all you do is you set a product name parameter, and then you fill out this getSensors method. This getSensors method gets called every 10 seconds, since we set it to 10 seconds. Every time the metrics are collected, your getSensors method gets called. And in there, for whatever sensors you want to send a metric value for, you just call this setSensor method on it. So in this case, I'm using 2 different sensors. One that's a simple sensor, that's the number of people who are excited about OpenTelemetry, and I set it to a random number. Obviously, in your metrics, you're probably not going to use a random number, but it makes the code smaller. I'm also setting one that has multiple options to it. So in this case, it's a favorite museum. You can have the Bonsai Museum, the Spy Museum, the Postal Museum. Those are all museums here in DC, none of which I've been to. So if any of you want to go see a museum, here's a couple suggestions. And that's it. You register the class, and then all of a sudden your metric is there, and you'll start to see it, so you can do your own stuff. So let's see that metric that I just created in CoreLogix, and you'll see, what did I choose? Favorite museum. Nope. Excited about hotel. I think I picked favorite museum. And I run the query, and you'll see that it has showing all of the options, and it'll show them for all the different servers in question, or you could pull them all together. This is just whatever your chart is. I know this looks ugly. It's very colorful, but it's ugly because it's just random numbers, so of course it looks like random data, right? But for your application, you can have it be, number of current logged in users, or whatever your needs are for your application, you can build. And this is the same thing that you've been able to do for the last several years in IRIS. It's just now it sends all the data through OpenTelemetry. Logs, let's check in on that log message, make sure that it got to CoreLogix. So I'm going to, in CoreLogix, I'm going to search for the word rocks, and I'm going to see that the message appeared. This little display of what the log messages are can be customized, but I'm showing the version here that has everything in it so that you can see all the information that comes through. So when a signal goes from an application to an observability platform, it gets tagged with a lot of metadata as well. So you see a lot of metadata here. It pulled it out, the actual message, OpenTelemetry rocks, from the severity level, fatal, but it also has what server it was that this had a problem on. If it's running in Kubernetes, the fact that it's running in Kubernetes and its namespace. You'll see what version of OpenTelemetry was used to collect it. You'll see the timestamps. You see all kinds of other information that will really help you observe your system really well. And all of your metrics, all of your signals, I should say, get tagged with this kind of metadata, so you can really work on it in a very detailed way. So that's what I wanted to show you today for as far as, hey, what does IRIS exporting to OpenTelemetry look like? There's just one more area that I wanted to talk about, which is how to debug all of this. So there are more systems involved. So it's IRIS talking to a receiver, talking to your backend. So I want to just say, hey, if your signal is not finding its way over, how do you find it? And the first thing to look is in the IRIS process list. If you have the OTel process running here, which I think in a second I'll scroll down and find, that means that the OpenTelemetry collector is running as part of your IRIS instance. If it's not, that probably means you either didn't configure it correctly or it crashed for some reason. The problem is on the IRIS side. So there you go. It'll be called sys.monitor.otel. The next thing to look at is if that's running, how about the receiver? Let's look at how the receiver is configured. So the receiver is a standard OpenTelemetry piece of software, and like all things in kind of the modern CNCF world, it's all configured through YAML files. So here's a YAML file. It differs a little bit depending on what exactly the connector is that you're running. But they all will have this pipeline section. They'll have the concept will be you have receivers of what data this particular receiver should be expecting to come in. Processors, so as the data comes in, how do you want to filter it or batch it up or whatever else that you want to do? And then exporters, how do you want it to go further down? So on the receiver side, you want to turn on OTLP, that's the OpenTelemetry wire protocol, but it's not wire, obviously. L stands for something. The processors, you probably don't have to monkey with the processors at all for anything IRIS specific. You've already filtered it out on the IRIS side. And then exporters. So whatever backend system you're going to send it to, they'll tell you, hey, here's how you want to configure your exporter for OpenTelemetry. One trick here is you can add debug to this list of exporters, and the log files for your exporter, for the receiver, I should say, will have all kinds of gory information about whether it could connect to your backend system or not. So that's really helpful if you got the URL wrong or you made a typo in your API key or whatever it might be. That is it. That is the end of my demo. I just say thank you. All right, on to you, Michelle. You are next.
Aha. All right, you can put that down. All right. Well, great. So that was some good setup for what we already have so far as observability of the platform. And the next level we want to talk about is traces. So this is new to the InterSystems world, right? I'll talk about some partial, what I call partial alternatives in a little bit. But let's start with why do we care about traces? So this is for really your runtime context, right? It's not sort of at a certain point you're trying to troubleshoot and debug. This is you've got something that's running real time and you're trying to observe what's going on, right? And for analytics, right? So think about site reliability or incident response. These are going to be your typical use cases. You could also use it for debugging like anything else, but that's not your typical use case for this. So yeah, this is a net new capability. We're going to be introducing a new package, right? The %sys OTel package. And it implements the OpenTelemetry standard, right? So you can read all about it. And basically, if you read that standard, that's what's going to pop out in our API. Okay, so the things it's going to provide, it's going to, well, here, let me go my next, because some people are visual, so I don't know if it's going to help. But so it collects spans in what is called a trace. Okay, so my little paint drawing here, right, simple drawing here, is trying to illustrate is you've got some code path that gets repeated, right? And in one of these cases, something different happened, right? Oh no, something broke, probably, right? You can dive into this trace and see exactly what the context was at that time that maybe made things go awry, okay? So some of the things you're gonna include in a span are gonna be some metadata, right? Like names and timestamp, type information, right? You're gonna include your custom application state, I don't know, patient ID, I don't know, something like that. You're going to include potentially references to other spans, right? So if you're someone who's used fire data, for instance, there's a lot of references between different entities. It's the same kind of idea, right? You've got a reference to a similar entity. It's in a link. And then you've got events. That's really very powerful as well, right? So you've gotten to a certain point in your code path, and there's an event that you want to log. Okay, I got to this point, right? All right, now, so that's all very powerful. This is an API, right? So you're going to be implementing it in your application, right? And so this is something you're using as a developer, right? As an application developer. So this might remind you of some capabilities that are already available in the platform, but like I say, they're partial, right? So MonLBL, if you ever worked with the WRC or you've ever done any performance optimization, you've used this tool, right? It gives you a heat map of your code, your different lines of code. You've got the trace utility and associated class. You've got %stack utility, right? And again, a function that goes with that. You've got your application error log utility. And in BPL, you have the trace action, right? And Bob also talked about the microservice case. If you use productions, then you're familiar with the message viewer that does something similar, right? So now in the trace element for BPL, it's really logging, right? It's a nice println, right? So it's not nearly as sophisticated as the trace that we're talking about here that comes with OTel. All right, so just to give you some idea of how what we're talking about, this new capability that we're introducing, how it relates to what exists today. Okay, so you're gonna be able to log error information, application state, you know, what was the last line that got called. You could even use some of these things, right? Some of these APIs whenever you implement your tracing. But it's gonna give you that extra robustness, I guess, for that real-time use case. Okay, so let's dive into a very simple example. All right, so this is my hello world routine, demo routine. I'm gonna go through it line by line with you, and then I'm gonna highlight the work just to help you really understand how you would use this in your application. Now, I wanna remind you that API is in development. Please don't nitpick, okay, and things will be changing. But if you have any strong opinions, please do come to me and Bob and let us know, okay? So we start out, we get a config, all right? Now, this should be immutable. Why would I do this? It's just to make it easy to illustrate, okay? All right, so I take that config, I give it to a provider, right, which is gonna be giving me my trace objects, right? And then I ask that provider to give me the trace object, and then I insert my first span. And here I called it span root, okay? And I give that span a name called demo. And you'll see that in all of these cases, I name my spans the same as the routine label. Okay, that's just because it makes it easy for me to map them. Okay, and now I initialize my ID number, and I say, okay, go to label B. I want to do some work there. I create a new span, right, at this new label. I populate ID, and I say, actually, I want to do some more work over in label A. Again, in label A, I create a new span. I do the work of writing something to my I/O device, and then I add an event, a really simple event, greeted, and I'm using just local time for now, right? Local time format, and Then I end my span. Okay, so what happens? Then I go back to label B. I end my span there, and I go back to demo, and I end my span there, and I'm done. Yay! So we printed hello world, right? All right, so very simple, very, very simple. Now, here's the work I'm highlighting, right? Everything else is more or less boilerplate, right? Like, very simple what I'm doing here. I'm just kind of popping from one label to another and maybe doing something little that's simple. And the main point here, right, is we have the same tracer that's getting used, right? Tracer object, and I'm inserting spans to that one OREF, right? Okay. Now, it's very simple. This is really a single branched tree, right? But you can imagine you can make it more complex, right? You start adding some conditions, you start having jobs, right? Distributed work, right? And then your single branched tree could actually become something more like a graph, right? Or more like what we have now with abstract sets, right? Like a mathematical set, actually, where you have many different tracer objects, right? And you have pointers to all the different graphs or trees that you're dealing with. So lots of ways to make this more complex. Yeah, and that's all I had for discussing traces. I'm very interested in how many of you have questions, because there's a lot of stuff. I actually think should I go back to this one?
Sure. Can you go over to the one right after the our addresses slide?
Yeah.
The one after that. There we go. So all of the sessions have this slide. You've probably seen this slide at whatever other sessions you've been to. That's the please take the survey and tell us how we did and how well we can be. This is how we get better, but it is also, I just, not as a bribe, I also, as a completely separate thing, I want to mention, I have some open telemetry stickers for your laptop and such in the back there. There might be a few left there still. I know folks are grabbing them. So if you want one to add to your laptop or your water bottle, please do. It is definitely not a bribe to say nice things on the survey. All right, now we can do questions and answers. I'm supposed to show you the EAPs. There are early access programs. None of them are particularly OTel specific, but okay, sorry. Now we're good. Now we could do Q&A.
All right, so yeah, so questions. I see Arnie's hand right there. Yeah, go ahead.
I was just wondering if you have visualization tools for the tracing that can show complex.
Well, so that's the point of using OTel, right? Is you plug into a whole ecosystem of those tools and you get to choose. Very likely, if you already have an application deployed in the cloud, you've got a decision on that front already. And so once we provide this trace capability and you implement it in your own application, it'll show up in whatever tool you already have.
So you're saying there's already an ecosystem.
Exactly.
Right, Coralogix has a tool for it. Coralogix has a tool for it. Dynatrace will visualize these. Signos will visualize these. So it's your observability platform, and we don't have to write the UI, so that makes things all better for everyone.
I might just say one word. One of the reasons I'm so very excited about this OTel integration is in the past you had to use either some command line utility to get the information you wanted, or the system management portal. And especially when you're deploying to the cloud, you want to avoid having to go to the SMP, right? This is kind of common knowledge, right? So now we'll be able to use plug into much more robust observability platforms, right, for that purpose, instead of having this weirdo side thing for IRIS. Yeah.
Yeah.
So when we talk about tracing, a lot of the time, what really matters is distributed tracing throughout the application from the web front end all the way through to the back end. And today we use OTel across the board from our front door for our ingress controllers all the way through our web layers and into the web gateway where we lose visibility. So will the span or the trace IDs come from the web gateway, populate into the trace in object script? Is that going to be something?
So what we're talking about here is on the object script side. So there's already APIs to get some of the information you're asking for from the web gateway, but it's not going to be all the information you're looking for.
And that's where
we would have to instrument it in the web gateway ourselves in order to make that possible, right? Yeah.
Got it. So what I guess what I would ask for then, as like if I have a strong opinion, I just need the ability to inject that trace ID when I make the object script call and be able to do that. The other thing I would follow that up with, we have a lot of our calls where we drop to async, where we actually end the web request, and then the web request is waiting for cache to execute cache IRIS, sorry, we're still on legacy stuff in a lot of places. But we then wait on a request to go back from object script back to our web front end. We're implementing some custom stuff now where we're actually injecting an ID that we have the object script send that trace back out when it makes the call to our web or APIs on the edge. So that would be something I would suggest too. So.
That's a good suggestion, yeah.
Awesome, very helpful, thank you. Well, I know Dimitri is patiently waiting. Anyone else?
So, thank you. It's a great start. At least we have something now. But the question is, like, how it impacts performance. We are speaking about performance. We observe it as well. And when we add all of these logging, tracing, we don't want to impact performance. So and also like how it impacts counters we have beside like glorefs, glosets, because it's some API somehow working, and also it connects with some agent. Like, does it like work with network? Like, if network impacts it or like that? Yeah, and actually it looks like would require quite a lot of work if I would want to see a big picture what happening in my big application, and like I would need to add it to many places in my code. It requires quite a lot of work, and with such I don't know about it's in open telemetry or it's just in parts like profiling. How would it be possible without adding all these calls manually, just have profiling?
All right, there's a bunch of questions in there. Let's see, to answer the last one first, profiling. So the OpenTelemetry committee is working on standards for profiles and profiling. That's not out yet. The beauty of working with a standard like OpenTelemetry, we don't have to invent it ourselves, and it will work with a lot of tooling that's out there once that's available. So at that point, then we'll talk about it. I can't answer that. You talked about overhead, right? What's the overhead of doing any of this, right? For metrics and logs, very, very low. Again, the beauty of working with an existing standard, an existing code base that's widely used on the internet is we don't have to optimize the heck out of it. Traces, we don't know yet.
Even I would say it depends on how it's used, right? So you could be extremely granular with your traces, and that's going to probably have a larger impact on your performance. Or you can be more selective about where you use it to reduce it. But even then, in the ideal case, the way we'll be implementing it, it won't be any worse than other object script calls, right? So it should still be performant.
All right, that is it. We are out of time. Thank you so much for coming. This has been a terrific session. You've been an awesome audience. Thank you so much, and I'll be seeing you around.